Welcome to the Data Leadership Lessons Podcast. I'm your host, Anthony J. Algman. Data is everywhere in our businesses, and it takes leadership to make the most of it. We bring you the people, stories, and lessons to help you become a data leader. We've partnered with Dataversity to provide listeners with 20% off your first training center purchase with promo code ALGMANDL. Go to dataleadershiptraining.com to learn more. Today, on episode 70, we welcome Aran Khanna. Aran likes to say he was born in the cloud. His birthplace is Seattle. He got his first job with Microsoft, and a startup he worked for subsequently was bought out by Amazon Web Services. While working in the tech sphere, Aran saw firsthand the misalignment between what digital platforms offered for cloud service management and what customers actually needed. Teaming up with his brother Nikhil, Aran founded Archera, a company that uses machine learning to help organizations automate and de-risk their cloud strategies. With Archera, Aran hopes to put control back into the hands of developers and business leaders so they can use the resources they need when they need them without hemorrhaging time and money. Aran, welcome to the show.
Anthony, thank you so much for having me. It's great to be here.
So like we do, all of our first-time guests, just take a few minutes and just give us a little bit of the story of Aran and what happened and what you did in your career leading up to Archera and kind of how those experiences all fit together to doing what you do now.
Yeah, so I think you gave a great intro, but maybe just to dig in a little bit, I was born and raised in Seattle, like you said, but actually before I even started working in the technology space, I was, funnily enough, gung-ho dead set on being in biology, particularly synthetic biology. And my first internship ever was at this little synthetic biology company called Targeted Growth. And I actually worked downstairs from the computational biologist folks. I didn't know a lick of computer science, but what I realized when in the cafeteria one day is that my experiments were taking 2 to 3 weeks to gestate and give me results. And this guy could just click the enter key and get results immediately. And I started to understand that, hey, I can get a lot more leverage out of this code thing than out of, shuffling around atoms on a lab bench all day. So I really kind of dove headfirst into computer science really early in my career in high school there. And like you said, the rest is kind of history. My first job was at Microsoft on this little project coming out of Microsoft Research called Red Dog that eventually became Windows Azure. So I saw kind of the internals of the cloud and how the economics of renting out a computer over the internet actually worked out, really get defined from the ground up. But funnily enough, I was actually in college at this time at Harvard studying computer science and math. And my side projects were really around data privacy, particularly data privacy with large social platforms that were gaining a lot of steam in the early 2010s, particularly around my demographic, which was the millennials. So all of my friends were on Facebook Messenger, all of them were on Venmo. And what I realized was that the growth-minded defaults that were being set by those platforms actually caused their customers, their users, to leak tons of really private and sensitive data. And so my side projects were looking at how I could build things, tools like Chrome extensions to actually educate the users of these platforms on the data that we're sharing and often the really pernicious consequences of that data when it was aggregated at scale and used to build a profile on them. And this is not just something that Facebook or Venmo can do. Anyone with access to the internet could go and look at this stuff because that data was being leaked by those platforms all over the internet.
I suspected, and Facebook Messenger stands out in my mind because I suspect anyone who wants me to use their thing that badly, like in that way, it always kind of makes me feel uneasy. And I never had even suspected that it would be making all of my data or some of my data available widely. I just assumed they were going to just find more information that they could use themselves. But this sounds like there were some flaws in that underlying technology that caused, I have to imagine they weren't intentionally making all that data available widely, were they?
Well, actually, it was intentional. It's kind of funny. It was part of the, I think, ethos early on in the platforms. They gave a TED talk on this, where, the core idea was that when, Zuckerberg, in the case of Facebook, was really defining the early vision, he said something very material, which is, look, we just decided that sharing would be the default. And we went for it. So the defaults in these platforms were actually constructed in a way where, you could go and get your privacy back by going deep into the menu and flipping the switches the other way. But having that default means that most people won't do that. And because they're sharing more publicly, more of their friends will look at that. They'll see that those people are on the platform and they'll join. So there's this growth motive that actually caused this to actually be a kind of real tangible decision, not just an oversight, because of the fact that it drove growth. And that's really, I think, when I look at my career more broadly, a theme that even now with what I'm doing with cloud platform management and pricing transparency really strings through, because what I've seen is that as platforms, be they social platforms or cloud infrastructure platforms, grow bigger and bigger, they grow more complex and less transparent to the end users. And I think as a computer scientist, once I entered this field, I viewed it as my goal to make tools to help increase that transparency to the end user, be it on the privacy side for consumers or on the cost and management side now with what I'm doing with AWS, Azure, and Google Cloud Platform.
That's really interesting. I think about that complexity of cloud environments, which is, like many data people, I mean, it's unavoidable that you're working in the cloud to some extent or another at this point. But it does feel like the mechanics and the pricing and the consumption has been deliberately made more confusing than it should be. And it's taken what I think a lot of the software as a service or as a service offerings in general are pretty good about telling you up front, here's what it's going to cost. This is your subscription. Here's Disney Plus for X dollars a month or X dollars a year. Like, you kind of learn that, and it's an all you can consume. But on the back end, when you're using the underlying services, infrastructure as a service, it gets very granular and very confusing, and you don't know. You can figure out what you spent and what you spent it on, but good luck predicting what you're about to spend and knowing clearly what your parameters are going to be of that spend.
And Anthony, you hit the nail on the head. That's the core problem. That when I was at AWS, even I was on the team that was launching Sagemaker and the suite of services around it. So it was 8 of us at the beginning. I think 800 by the time I left. So they really grew that organization quickly, and we launched a lot of products. But the unique thing about that set of products in the cloud environment, and obviously it's very related to data processing, was that they use the most expensive hardware primitives. You're not using just general raw compute. You're using GPUs most of the time, especially for deep learning, which is where a lot of my research lay. And then a lot of the products that I released actually were built around, core vision, language, et cetera, sort of deep learning models. And as a function of that, I saw viscerally as I was trying to sell these new products to customers how difficult it was, because for every just server sitting in a data center, and this actually, I would say, partially, yes, it's the fault of the cloud platforms, but partially it's the fact that they're trying to take something that, I don't know if you've ever operated in an on-prem environment. It's incredibly complex, the number of ways that you can actually purchase servers from Dell and HP or whoever and stick them in the data center. They're trying to narrow down all that complexity into a set of APIs, and what comes out the other end, for better or worse, is that you have 36, 37, 72, combinatorially large number of ways to purchase any given server. And then you have hundreds of servers. So you get this massive explosion. And just to give you a little stat on it, because I know you have some real data nerds who listen to this podcast, if you just have 100 resources and you want to say, look, I know how long I want to commit to each box. I want this one for a year, this one for, hour by hour, this one for 3 years. And then you were to say, look, given all the pricing models in AWS, where should I put, $500 if I can spend that up front amongst all of these options to maximize that return on my upfront dollars in terms of savings? That's an NP hard problem. You're going to have to churn through literally tens of millions of different combinations to find the right answer. And that's just one dimension. And they have other dimensions like flexibility, like timeline, et cetera, that make it even more complex. So as a function of trying to be competitive with every single SKU you can stick in a data center, you get this combinatorial explosion on the back end. But, to fix it, it means actually going in and doing a lot of difficult economic modeling. It might actually create more friction for them to create revenue, because all those inefficiencies that come from people purchasing the wrong resources hit the bottom line. So you see this sort of natural misalignment in trying to solve this problem, frankly, and something that when I started the company, I was gung-ho and trying to figure out what is the new model, the automation first model, and the model where we can actually become a party to share risk with the customer, where we can actually solve this on their behalf and not really stick them in a situation where, they have a big commitment that they can't pay off to AWS because we messed up.
It's a really interesting point around this kind of extremely large combinatorial equation, because I think about it, and like for those of you who aren't big deep statistical nerds out there, there's one thing that I'll draw an analogy for you that I think will help to understand, because we're talking about thousands of variables probably here in terms of the number of things that could be calculated, what we're using it for, the hardware, all of this stuff. Yep. It's very complicated. But even in a deck of cards, 52 cards in a deck of cards that you deal out, and you're talking about 52 unique events. That's it. And to deal out all those cards. Chances are, if you go and do that right now, shuffle them up, deal them out, you will have an ordering of cards that has never happened before in the history of the universe. That's the power of combinatorial. Like, that's just a 52 factorial type of thing. And that alone will make it so that the numbers are incredible. So now you take that to thousands. Yeah, it's a bigger challenge than I think we realize in terms of how do you actually create a consistent, transparent, cost mechanism, just for understanding. If you're the cloud provider, how do you know what your cost is other than the dollars that you spend on things? But how do you attribute it to a service that you're offering and knowing whether or not that service is going to be profitable or at least break even, right? And so we see it on both sides of that very complex equation. So I imagine, and I'm just projecting, Archera has something to do with this in terms of being able to understand and navigate this scenario. But is that part of the origin story of this company? Is that part of why you decided to go out and create a business to do this? Because you realized how complex that is and how difficult it is for these companies out there to navigate a situation like that.
Well, very much so. And I think another big part of it was I was kind of solving my own problem. Because remember, when I was at AWS, I was trying to sell incredibly expensive GPU hardware to all of these customers. And what I realized was that, the Airbnbs and the Netflix of the world, they actually built their own version of what, would eventually become Archera in-house as a snowflake, because they had tens of engineers and data scientists to throw at this. But everyone else was using spreadsheets to try and solve NP hard problems. And I think that, if you're in the data space, you realize that past a certain point, the spreadsheets won't cut it. You got to go to Jupyter notebooks and, big data clusters to really understand what the optimal strategy is given all this volume of data, right? So what I started to realize was there's this big gap in the market, and all of the tools and the vendors that I was selling to my customers to try and obviate this problem, I think you said it really, really well. They were all backwards looking. They could tell you what you spent yesterday, but in terms of predicting the future, they were very, very poor. And beyond that, they stuck to this very staid set of best practices where instead of saying, hey, for this server, it might live for 2 months, for this server, it might live for 10 months. How do we really balance and optimize on a server by server basis? They said, look, I don't want to go solve that NP hard problem. How about for all your servers, you choose 1 year or 3 year? For all your servers, you choose 0% or 50% upfront. So they take that massive space where some really optimal solutions exist and try and cut it down and really leave all these customers with fairly suboptimal solutions and really low visibility of what's going to happen in the future. So these customers are basically jumping off a cliff blindfolded, not knowing what's on the other side. And that was a huge problem. It led to them saying, look, I don't want to use these platforms. I don't want to follow your best practices. I don't want to even turn on this service. So really, it slowed innovation. And my goal was to say, how do we bring what the Netflixes and the Apples and the Airbnbs of the world are doing with tens or 20 developers just dedicated to this problem, and bring that to the rest of the cloud community, the folks who are just starting with adopting cloud. So we decided to build a different model, one where we were predictive first. So we really try to get in and help you build those predictions, and then we used those hard NP hard solving kind of algorithms on large data processing clusters to really find those optimal solutions. And then finally, because of the automation piece where we could actually execute those solutions and the much higher degree of fidelity in our forecast, we actually said, look, Mr. Mrs. Customer, if we get it wrong, we'll take all that commitment risk right off your books. We'll actually insure that plan and we'll share the risk with you so you don't have to be on the hook anymore. So really trying to reinvent the model in a different way where we can say, look, everything on the visibility side that's come up to this point has been great, but it's really difficult. It takes your engineers pulling spreadsheets and typing in CLI commands to go and make it actionable. And there's really no visibility into the future or risk management for you. If you take these recommendations and they go south, well, yeah, you can kick out the vendor, but you're still left with a massive bill. So we tried to solve all those problems in a very different way, where you can come in and have one person in 4 hours a quarter instead of 4 hours a week go and do that attribution, build those basic forecasts, build that really complex purchasing model with an easy button. So you don't have to go and tune every single contract and try and solve an NP hard problem in a spreadsheet, and then say, look, for 50% of this, if it goes unused, we'll just take it right off your books. So there's no skin off your back.
I think 4 hours a week is generous. Like, I think that it could be 4 hours a day. I mean, I've seen organizations that have enough complexity, but not enough development resources that they just throw a person at it nearly full time. Like, this is what they do, is try to manage that. So, and it makes sense that very large or larger organizations that are heavily data driven in their core business operations, they're going to have a team and they're going to be able to invest the money, which is also costly, to develop some of these kinds of solutions, or something probably bespoke and customized uniquely for them and the way they do business. That's fine, but that is a small subset of those organizations out there that need this kind of understanding. And I think about the natural, like, human reaction to some of these things in cloud, because now I think every business has some cloud presence, or has at least very minimally considered it and has a plan for using it in some capacity. But what scares me is, people are tend to be slower to evolve than technology, especially when we think about our oversight and governance and policies related to spend and things like that. It's tough to figure out the new rules. But when we think about an innovative, rapid development type of world of cloud, we need to be very careful about the spend, obviously, because we don't want to accidentally charge up a bill that we had no real visibility into. So that's a problem. And then also, people need to have some independence of being able to work innovatively in one of these environments. So they can't be totally prescriptive on what they're about to do. And what scares me in the cloud, and one of the things, because you talked about how some of this obfuscation has actually slowed some of the development, our internal teams also struggle with that natural default of saying, when we're scared, don't do anything, or lock it down, or keep people from doing it. It's like that hits at the very core of what makes cloud valuable. And so there's these weird economics or weird forces that happen in how we're adopting these in businesses of all kinds. And these are big problems to overcome. And so I think by addressing some of the pricing transparency and predictability, we'll have not only a cost benefit that's very direct. I love the idea of the insurance piece of it, to really stand up and say, hey, we can provide you protection. And that's a big bonus for a lot of organizations, because they're going to tend to be risk averse. But we can also leverage that understanding to help develop more appropriate policies and processes for people to use this technology that's so powerful. And I think that's a big piece as well. How much do you get into that in the work that you do at Archera? Or do you focus just kind of on that first one of, here, we're going to provide you this transparency, we're going to help you do what you're doing, and then you're going to figure out the other stuff on your own because that's unique to your business?
Yeah. So actually, what we call the scenario planning in our product is actually a big part of it. And, you actually hit the nail on the head, Anthony, when you said people move to the cloud to move faster. They move for rapid innovation. Now, some people move for cost savings. And I would say to those people, maybe that's not the right reason. But really, the idea is that if you move to the cloud, your engineers, your data scientists, they can move much faster. They can innovate faster. But then you run across exactly what you said, this false dichotomy where you have, hey, you can either govern this thing with an iron fist and not have cost overruns, not have billing surprises, but really slow down innovation, or you can let everyone run wild in the candy store with a credit card. All the engineers, all the data scientists, just give them a card and let them charge up everything. And maybe you can run behind them afterwards and clean things up. But really, that's the false dichotomy that a lot of organizations are living with. And part of why we created Archera is to say, no, you don't have to live in one of these two worlds. You can get that rapid developer velocity while having spend controls that don't take a lot of engineering time or effort to go and implement. And that's done through changing the model from one that's visibility first to automation first, where a lot of the undifferentiated heavy lifting can be handled by automation. In fact, part of why we started with this commitments piece is because, unlike going and asking someone to turn something off or right sizing something, there's no potential impact to the underlying infrastructure. And the one thing that developers hate, especially data scientists, is people turning off the lights on them, right? Especially if they have data sitting in, something on like a disk or something, and the program just cleans it away and 3 weeks of work is gone. That's actually more costly than leaving that disk up. So it's stuff like that you can't really predict in the environment. So if you stick to making sure that you can go and play around with all these billing constructs on the back end, do that automatically, you can get the impact on the bill that would have come from all this engineering work with a purely automated process. So that's really why we started there. And then when we think about setting policy controls, it's really derived from the fact that we understand what is that end billing mechanism, that last step that will get to the final bill. We have good amounts of predictability there, and we can say, look, 50% of these policies here, it's just busy work and it's going to reduce the bill 10%. These are the 3 policies, if I show you this scenario, that'll really matter. Those are the only ones that you should put in place, because your goal is to make your engineers move fast while not blowing out your budget. That's really the only goal here, not to maximize spend and be or minimize spend and be draconian, because that's not why you're on the cloud in the first place.
It reminds me of a mantra I have, in that the cost of perfection is extremely expensive. And that's the key, is like, you need some measure of protection, but you don't want to be 100% you don't even want to be 100% efficient, because 100% efficient probably slows you down so much more in another way that doesn't even optimize the actual scenario. And so it's really interesting how you think about a series of complex decisions and what's in and what's out for a particular set of decisions, because that can make all the difference in the world. And I like your approach of saying, hey, here's the policies. There's a lot going on here, and they're helpful. They're just not helpful enough given the headaches that they're causing. And that, I think, is a good pragmatic way of approaching these highly complex situations, because we've already talked about how the math behind getting to a perfect answer is extremely difficult, if possible, right? And so we know optimization is theoretical but not practical in any way in terms of perfection. But if we put in the right kinds of gating mechanisms, the right kinds of controls, then we can get to something that's satisfactory across all accounts, and is largely going to give us most of the gains that we could have gotten if we spent infinite amounts of money, which we don't have, obviously.
Right. And it's really about, not just even the money, but the engineering time, right? That's the scarce commodity in many respects. So, if you're making the recommendation to move everything to Spot and make it robust to random failures, you're basically saying, go do a 3-month engineering project to get the cost down, which is great. It could bring down the cost lower than what we're doing today. But what if you click this button and get 70% of that just by buying the right set of commitments? And I think that's the sort of eye-opening that we want to do to our customers, so they can move fast with confidence and not have to get interrupts fired at them all the time by random people who don't really understand where the yield is going to come from.
Well, that makes me think too. Like, I have developers that I've worked with that would love to make everything event driven, using Spot instances, using the most efficient, cost efficient things. But we have to be working with an enterprise application that's been ported to the cloud that isn't necessarily well optimized for running that environment. Like, okay, yeah, we've moved it to the cloud, but you're just running on EC2 instances in Amazon that are up all the time. Like, that's not really re-engineering it for the cloud. That's simply installing it in the cloud. And that causes us challenges when, I think, especially when we talk about very large organizations, but actually this is more true now in mid-sized and smaller organizations too, is when much of your development work is about integrating applications and connecting those and the data flows that are tied to them. we have limitations outside of our control all over the place because of what those applications are designed to do or able to support. And so very rarely does the business, who may not be as deeply understanding of the technology constructs, very rarely does the business make the determination based on the back end architecture of the platforms that they're choosing. It's usually about the functionality and the user interface and the things that they can tell are providing them value on the business side, but it can cause, a back end challenge that is substantial.
Yeah. And I think we see this all the time. One of the key things that we work with small and mid-sized companies who are migrating on is the fact that they always want to say, look, we're going to migrate and go serverless from day one. And we have to say, look, this is not realistic. It could take 6 months, it could take 9 months. It's a large re-engineering project. It's not a lift and shift, to really make it a robust cloud native solution, to put it into containers on Kubernetes or put it into Lambdas. That's a long-term project. And what customers are being fed by the cloud vendors right now is go buy the commitment that gives you the lowest savings rate, but the highest flexibility, because we know you really want to move to serverless. And, I'm sure you could do it in a year. The thing is that when we go and talk to those customers, we show them, look, if you get a 3-year commitment for those EC2 instances, by the way, you can sell it back to us whenever you're done migrating. But after, a year, you're actually better off from a savings perspective versus getting that really low savings rate thing. Problem is the risk aversion leads them down this path of selecting, essentially what I think is a bit of red herring from the cloud vendors, things like compute savings plans that only give you like low double digits savings with high degrees of flexibility, but you're not taking full advantage of the fact that you have a lot more predictability. And if you really think about the path to get things into a cloud native state, it takes a lot longer than most folks actually forecast. So really allowing for that buffer period, and that's where our insurance comes in, but also just the analysis comes in, can really help engineering teams start to think with that financial mindset instead of saying, here's the optimal, let me do everything to work backwards from there.
Mm-hmm. And I'm going to ask you a question, and if this is something that you can't provide a lot of detail into, or are not comfortable due to your partnerships or whatever, that's fine, and we can move away from it. But I'm curious, are there differences in the major cloud providers out there that you might want to consider if you're in a entrepreneur that's looking to do more in the cloud, but you only really know of AWS, or Azure or Google Cloud? Like, are there any decisions points that can be generalized at that level, or is it really something that really depends on a lot more specific workload?
Well, so it's almost yes and yes, right? It does depend a bit on the specific workload, but there also are some material differences between the platforms that are worth considering. One of the interesting things that we've seen is that most small organizations and large organizations now, I'd say over 75%, are going with a multi-cloud strategy. And part of what's driving that is just a function of the engineers who are building the application saying, I'm going to select the best tool for the job. Right? If it's the right, BigQuery, for example, which is much better in my opinion than, QuickSight to do my data analysis, or I think the TensorFlow support's much better on Google Cloud, I'm going to go do my analytics there, even though the web serving and the CDN is much better over at AWS, right? For example. So I think you get naturally, as you move into a cloud first approach, into a multi-cloud state, given the differences in the service offerings at an application level, right? What's the best tool for the application? On the other side, what's very interesting is you're seeing a lot of competition and differentiation happening at the commitments and the contracts level, which is what we've been talking a lot about. For example, AWS doesn't let you commit to storage, whereas Azure has storage commitments. So that might be actually a material consideration if you're looking at where do I store all of my blob data, for example. So there are some material differences, and this is where a lot of the complexity comes in, right? We talked a lot about the single cloud complexity, but now imagine figuring out where do I put the marginal workload. It becomes much, much harder. So that's where also I think we're trying with scenario planning, which I mentioned earlier, to help elucidate some of that, saying, hey, if I have to store N bytes every day and I need to serve this many requests, where is the best stack to run that, given the data I have right now on where that application is hosted? So those are the kind of questions that we try and help customers answer, particularly from a pricing standpoint. But again, it's a very early, I think, very early days in the cloud market. We don't even have commitments right now for data transfer costs, and that's a big pain. And we're seeing Cloudflare, for example, get really aggressive with pricing there. So I think, with the move to multi-cloud, the fact that a lot of the primitives are very well defined now. So Kubernetes on Azure is going to look similar to Kubernetes on Google, which is going to look similar to Kubernetes on AWS, right? So given that, I think we're going to see a lot more innovation, a lot more complexity at that pricing layer come out. And then obviously there are managed services where you're going to have vendors that are just going to stay best in class. I think on the machine learning side, Google's probably going to stay best in class there, just given all the investments and the data that they have. Probably on the enterprise side and enterprise identity, I highly recommend going with the Microsoft stack, and I think they're going to do great things there and probably stay the leader. So the managed services are different, but for the commodity compute, I think we're going to see a lot more innovation, a lot more competition on that pricing layer, particularly around those commitments and contracts.
I like the notion of multi-cloud as a innovation and kind of best of breed type of decision versus I think what drove a lot of early multi-cloud decisions was purely from like a disaster recovery business continuity type of thing where I think now
we've seen AWS go down a few times in the last few months, so that's not necessarily
it's not necessarily bad, but the problem is that even if you're not on AWS or you're in multi-cloud, you're probably still going to have problems if AWS goes down. So we learned that too. And that's, for most, I think, especially like if we're talking mid-sized businesses and even most enterprises, frankly, like you're one of many, many, many customers. If they have a massive outage, you're going to have problems, like even if you're not a direct customer of them. And so managing around that is more or less worthwhile depending on your workloads and specific nature of business. But I think too, that multi-cloud strategy gives you some of that, and it allows you to have some redundancy, but it doesn't have like I would just think about my decision point 10 years ago would be, well, do I really want to incur, some approximation of twice the cost for no additional functionality just for the peace of mind of having this multi-cloud strategy? But you think about all the extra development work and all the extra like connections and testing, and then you have differences in their actual services. Yeah. That may be a difficult sell for a lot of organizations that barely have enough resources to do what they want to do in the first place, let alone pay for it twice. And so I think, though, the multi-cloud strategy is really interesting from that innovation perspective, saying, hey, there are some services that are better in certain environments. There's the core stuff that everybody can do pretty well at this point, but there's some differences in terms of the pricing and all of that. And so I think that the calculus gets more and more complicated, but the differentiation and like what a wrong answer means now versus what it meant 10, 15 years ago is much different. Like everyone is pretty good. You can probably do most of what you want to do with any of them. Then you can start looking at the finer points, right?
And that's exactly it. I think it comes back down to our original conversation a few minutes ago around developer velocity. It's the real reason people move to the cloud. And I remember my Amazon and Azure talking points. The reason to only go with one cloud is, I get price reductions and, negotiating volume. But if you followed our conversation, the thing is that you don't move to the cloud to save money. And in fact, in many ways, running multi-cloud, you could save more money because there are things like, as I mentioned, storage commitments on Azure. It could be cheaper, even net of the data transfer costs, to go store stuff there if you have the right strategy. And there's going to be more and more competition. So from my perspective, I think the idea that you move into a multi-cloud posture because of the fact that it allows engineers to move faster. And I think going forward, you're going to see more tools like Archera that say, hey, we will help you become cloud agnostic at managing your costs and commitments, doing that in an automated way without needing a cost engineer for Azure, a cost engineer for Google, a cost engineer for AWS. I think the same thing's going to be done with observability. We're seeing that. The same thing's going to be done with security. We're seeing that. So I think as we move forward, it's going to be easier and easier to run those sort of applications. And like you said, the risk is much, much lower to the end developer, to the end business, going and experimenting and building stuff on multiple platforms.
Yeah, I think that summarizes it very well. And in the last couple minutes that we have, I really want to understand a little bit more deeply, like what Archera does to help organizations solve this? Especially like, I wonder if there's the small business owners out there, the entrepreneurs, or the leaders in small and mid-sized businesses saying, well, this all sounds good, but I don't know what to do about this and whether or not this is appropriate for me or not. Can you help us understand, where do you connect into those kinds of organizations, and who is buying Archera? Is it the is it the CEO, the CIO, or who cares about this inside these organizations?
Yeah, I mean, it really depends on the organization and particularly the size. So for those small and mid-sized organizations that you mentioned, often the CTO or a CEO, particularly a technical CEO, would be the end buyer, and one of the users would be the person who's usually the sole DevOps engineer who has to manage all of the platforms and servers, and cost is item number 5 on the list, and they love the fact that this is ready to go in 15 minutes. You plug it in via an IAM role and a quick Helm chart if you have Kubernetes to all of the cloud platforms you're using. And then right out of the back end of that, you get suggestions with low risk, high impact, where you can click a button, you can call it an easy button, and really put in place all the common cost controls that would take a dedicated engineer. Even with AWS's tool updates, you need to go and set everything up by hand. We can automate things like the tagging, the forecasting, the alerting, and anomaly detection. All of that stuff comes right out of the box. And then finally, this commitment management and insurance piece. And you can get end to end set up in, like I said, 4 hours at the beginning of a quarter. Put the plan in place, and you don't have to look at it again until something goes wrong or there's an aberration. Then we'll come and tap you on the shoulder. But it's the ease of use, it's the ease of setup, and then the fast time to results that I think is really compelling for those small organizations. Larger organizations are a bit different, right? You're going to have probably a dedicated cost engineer at that point, not at the scale of like a 10-person team that you get from Netflix, but maybe one person, with this being 50% plus of their job. In that case, it's a function of, where are the gaps? You have a process in place. We don't want to throw out the baby with the bathwater, but you're not doing all of this stuff, and you particularly don't have a separate balance sheet where you're ensuring this. So what are the pieces of this platform that we can put in place to really augment your strategy without a large lift on the engineering side? And what we find is, actually, because folks aren't going and doing the NP hard problem right now, they're not solving it without very much work, even with very sophisticated organizations, we can get a pretty massive lift, if not just in a net savings perspective with a different basket of commitments, on a cash flow perspective, by doing things like solving that NP hard problem about where do you put each upfront dollar to get the highest yield. So we can really go in, and I think depending on where the gaps are in the strategy, sell into that office of the CIO to make those changes very quickly to yield large relative savings results, given the minimal amount of engineering time that we require to just plug the thing in.
Yeah, and I bet coming in the door, because you've done this in other places, you've looked at these things, you know what the patterns, typical usage patterns look like, so you probably have a fair gauge of what's likely to be occurring. Then you kind of validate that through the actual data that you're seeing in the customer environment, but you have a sense what it is going to be, I would imagine, because there's only so many cloud providers, right? There's only so many services. And so even though this is a really hard math problem, there are some patterns there that will get you 60-80% of the way pretty quickly, and that's going to be material for the cost spend of a lot of these organizations, I would imagine.
And that's spot on, right? We have data from all of these customers, scenarios where they're moving from IaaS to PaaS. We know, when AWS is going to reduce prices on certain instances, and we can actually incorporate that in. So there's a lot of, what I like to call tribal knowledge that ends up being built into how we forecast for customers. And just getting that even 10, 20, 30% better provides a material downstream impact without any engineering time spent. You just need a better forecast to commit with more certainty, and then you get much better results out the back end. So I think that's spot on.
Yeah, absolutely. So, Aran, unfortunately, we are all out of time. So I just want to, this has been really interesting, really insightful. Thank you for sharing your wisdom with us. And just thank you for being on the show today.
Well, thank you for having me, Anthony. And, folks want to learn more or find me, they can either find me on Twitter at AranKhanna, and they can actually go and try our platform for free. One of our main things is, along with the easy use, we try and make the core thing free to go and kick the tires on. So you can find that at archera.ai, archera.ai.
Great. And thank you all for joining us today. As always, you'll find more information about our guests and links in the show notes. And like Aran said, this week you'll also find a link to a free demo of Archera available to our audience. So check that out. Go to dataleadershiplessons.com to subscribe and check out past episodes and accelerate your journey with training at dataleadershiptraining.com. Stay safe during these unusual times and go make an impact.